Hello everyone, welcome back to our channel. Today we'll start a new concept called as Lami's theorem. So Lami's theorem is a part of equilibrium, that is the second module. So first we'll see when the Lami's theorem is applicable. Then after understanding the concept and conditions, we'll see what is the actual statement of the Lami's theorem. So start with the condition. So Lami's theorem is only applicable when the system is in equilibrium. Now what is the meaning of equilibrium? Equilibrium means stable state. So in the mode of equilibrium, the resultant of the system is equal to 0, means there is no unbalanced force present in the system. So if the system is in equilibrium, then and then only we can apply the Lami's theorem. The second condition to apply Lami's theorem is only three forces. So if the system consists of three forces, then and then only we can apply the Lami's theorem. We cannot apply the Lami's theorem for a system having 4 forces, 10 forces, right? Always remember Lami's theorem is applicable for only 3 forces. The next condition is concurrent force system. The Lami's theorem is only applicable for the concurrent force system. So when a system has 3 concurrent forces, then only we can apply the Lami's theorem. We cannot apply it for parallel or general force system. At the end, we have got all the forces should have same direction. All the forces should be pointed either in the outward direction or in the inward direction. If it has a combination of outward inward forces, then we cannot apply the Lami's theorem. So we'll repeat it one more time. So Lami's theorem is applicable if it satisfied all 4 conditions. So the condition number 1 is system should be in equilibrium. Condition number 2 is only 3 forces. Condition number 3 is concurrent force system. And condition number 4 is all forces should have the same direction, either outward or inward. So if it satisfied all 4 conditions, then only we'll apply the Lami's theorem. Now we'll see what is the Lami's theorem. So here we got force number 1, force number 2 and force number 3. Let us see whether it satisfied the condition or not. We'll assume that the system is in equilibrium. The resultant of the system is equal to 0. Then only 3 forces are acting on the system, F1, F2 and F3. Concurrent force system. The line of action of all the forces passes through a single point, so this is a concurrent force system. All forces should have the same direction. F1, F2, F3 all pointed in the same direction, outward direction. So it satisfied all 4 conditions. So here we can apply the Lami's theorem. So first we understand what is the statement of Lami's theorem. Any of the force is proportional to the sine of angle between remaining two forces. So any of the force means F1 is proportional to the sine of angle between remaining two forces. So here we'll apply the Lami's theorem for F1. So this is F1. The remaining two forces are F2 and F3. And the angle included between them is this angle here. So F1 divided by sine of angle between F2 and F3, that is theta 1. So in this way we can write. So actually it becomes F1 is proportional to the sine of theta 1. But here I will directly write the equation of Lami's theorem because the derivation is not that important. So it will not going to ask in the final exam. But application of Lami's theorem is always there for the concurrent force system. So we'll understand what is the final equation of the Lami's theorem. So F1 divided by sine theta 1. Then we'll consider the next force F2. Remaining two forces are F1 and F3. The included angle between F1 and F3 is this angle. The value of this angle is theta 2. Now we'll apply the Lami's theorem here. So F2 divided by sine of angle between F1 and F3, that is theta 2. So F2 divided by sine of theta 2. Now the remaining force is F3. And the rest of the two forces are F1 and F2. And the included angle between them is this angle. The value of this angle is theta 3. So here we can write the equation F3 divided by sine of angle between F1 and F2, that is theta 3. So F3 divided by sine of theta 3. So in this way we can write the equation. Always start with the force and find the angle between remaining two forces and write the sine relation for that. So this is how we can write the equation F1 divided by sine of theta 1 is equal to F2 divided by sine of theta 2 is equal to F3 divided by sine of theta 3. So always write the known value of the force at first. So first term of this equation will be the known value. It is impossible that all the values were unknown. So one value will be given. So you can start with that term and you can write the rest of the terms. Now we can compare this f1 sin theta 1 with f2 sin theta 2 to find the value of f2, and we can compare f1 sin theta 1 with f3 sin theta 3 to find the value of f3. So in this way we can solve this numerical. So we'll see one numerical based on the Lami's theorem. So the question is, determine the tension in the chord AB and BC for the equilibrium of 30 kg block. Now this question was asked in the May 2015 in the Mumbai University. So this is the given figure. It consists of chord AB, BC, and the tension is attached at point B. So don't consider this as an extra cable. Only cable or cord present here is AB and BC, and this is the weight which is attached to point B. Now this weight is given in terms of kg, so we should convert it into Newton to solve this numerical. So convert it into weight. So weight is equal to 30 kg into 9.81. So in this way we can convert a kg into Newton. The angle of AB with the horizontal is 30 degree. The angle of BC with the horizontal is 40 degree. When we cut this cable AB and BC, we will observe the tension. The tension present in this cable can be shown by the name T suffix B and C. So always the first letter will be the name of the joint and the next will be connecting point. Here also this cable starts from C and goes to B. So TCB. Here it will be, if you cut the cable, tension in B to A. So TBA. Here this force starts from point A. So T goes to point B. So TAB is the name of the tension. We show tension in the outward direction. That's why it is shown away from the point B. Also here it is shown away from the point A. So it acts in the outward direction. So this is very important point to remember. Tension always act away from the center, or it always act outward. So that's why we show the direction of tension like this. Now the tension present here, that is TAB and TBA, both have the same magnitude but they have the opposite direction. Here also the same case. Tension BC and tension CB both have the same magnitude but they are in opposite direction. So here we have got the figure like this. Here tension BA, here tension BC, and the weight shown here. So it forms a concurrent force system that we'll see in the next slide. So tension BC have the 40 degree angle, tension BA have the 30 degree angle with the horizontal, and the weight converted into Newton, so multiply it with 9.81. So this is the basic figure. Now we'll see whether it satisfies the Lami's theorem or not. So we'll see the system is in equilibrium. Then it consists of only three forces. All the forces have the same direction outward. Then it is a concurrent force system. So it satisfies the Lami's theorem. So here we can easily apply the Lami's theorem. So first we'll consider the weight 30 into 9.81. The remaining forces are TBA and TBC. So find the included angle between them. So the included angle between them is this angle. The value of this angle will be, the total angle is 180 degree from this point to this point. So from this angle, if you subtract 30 and 40, will get the remaining angle, which is the included angle. So 180 minus 30 minus 40 will give you the value of this angle. Now the next force is TBA. Now this is the unknown force. The remaining two forces are TBC and 30 into 9.81. The included angle between them is this angle. Now the value of this angle will be, first this angle is 90 degree and the remaining angle is 40 degree. So addition of 90 degree plus 40 degree will be the value of the included angle. So it is equal to TBA divided by sine of 90 plus 40. The next force is TBC. Rest of the forces are TBA and 30 into 9.81. The included angle between them is this angle. Now the value of this angle will be, the first angle is 90 degree and the rest angle is 30 degree. So it is 90 plus 30. So it is 120 degree. So here we can write the equation TBC divided by sine of 90 plus 30. So in this way we can approach. As we had discussed, we'll start with the known force. Here the known force is 30 into 9.81. So start with this force. Remaining forces are TBA, TBC. Find the angle between them. Next, go to the next force, TBA. Remaining two forces are TBC and 30. So find the angle between them. Then go to the last force, TBC. For TBC, two forces are TBA and 30 into 9.81. Find the angle between them. So this is the angle and write the equation. Now we'll rewrite this equation. The summation of this is equal to 110 TBA divided by sine of 130, TBC divided by sine of 120. Now we'll solve this equation to get the answer. So this is the previous equation. Now we'll compare 294.3 divided by sine of 10 with TBA divided by sine of 130. In order to find the TBA, we should cross multiply, that is 294.3 into sine of 130 divided by sine of 110. So this equal to TBA. This is very important term. Student able to find this equation but they don't able to find the values of unknown forces. For that we should compare these equations and find the value of TBA. Only compare these two equations. Don't consider this in this calculation. So 294.3 divided by sine of 110 is equal to TBA divided by sine of 130. To calculate TBA, just cross multiply it. Sine 130 goes here in the numerator. So 294.3 into sine of 130 divided by sine of 110, it is equal to TBA. Now the value of TBA is equal to, so this is the way we can find out. Now to find the value of TBC, we'll equate this term with this term. Let's see how to do it. So we'll equate this term with this term. So 294.3 divided by sine 110 is equal to TBC divided by sine of 120. So now this sine of 120 goes to the numerator. It gets multiplied here to find the value of TBC. That is 294.3 into sine of 120 divided by sine of 110. So it is equal to TBC. The value of TBC can be calculated and it is equal to 271.228 Newton. So in this way, using simple Lami's theorem, we can find it value of TBA and TBC in the easiest way. You can apply the conditions of equilibrium here, that is summation fx0 and summation of fy0 to calculate the value of TBA and TBC. But the Lami's theorem will give you the results quickly and it is very easy to calculate and there are very less chances of getting wrong results. If you find this video helpful, you can like this video, share this video and subscribe to our channel. Thank you very much.